You're watching a machine bend its knees backward, not forward, backward, like something that escaped from a biomechanic's nightmare. Then it rotates its torso 180 degrees while its legs stay planted, picks up a car engine component with the precision of a surgeon, and places it exactly where it needs to go. No hesitation, no recalibration, no human intervention. Boston Dynamics just released footage of their new Atlas robot, and if you think this is just another cool robot video, you're missing what's actually happening here. This isn't an upgrade, this is the moment humanoid robotics crossed a line we can't uncross. All right, Atlas doesn't move like a robot anymore. It moves like something that studied how humans move, then decided it could do better. And the implications of that single shift are about to rewrite the next 50 years of human civilization. For over a decade, Boston Dynamics has been the company that made robots do backflips and parkour while the rest of the world was still trying to make them walk without falling over. We all saw those videos, we all thought they were impressive, but they were also hydraulic powered, tethered to external systems, and controlled by human operators making real-time decisions. They were sophisticated puppets, expensive demonstrations of what might be possible someday. That someday just arrived. The new Atlas is fully electric, fully autonomous in its decision-making processes, and capable of movement ranges that exceed human capability while matching human adaptability. Boston Dynamics didn't just improve their robot, they fundamentally reimagined what a bipedal machine can be. Here's what changed. The old Atlas ran on hydraulics, powerful but loud, messy, and energy intensive. The new version is all electric, which means it's quieter, more efficient, and capable of operating for extended periods without the infrastructure nightmare of hydraulic systems. But the real breakthrough isn't the power source, it's the intelligence architecture. Atlas now makes spatial decisions in real time without human input. It sees an environment, calculates thousands of movement possibilities, and executes actions that would take a human years of training to perform. When it moves, it's not following a script, it's solving problems, and it's doing it at a speed that makes human reaction time look like slow motion. The video Boston Dynamics release shows Atlas working in a simulated automotive factory. It's picking up heavy components, navigating tight spaces, and adapting to obstacles that weren't programmed into its system. This is the critical detail most people are glossing over. The robot isn't executing predetermined tasks in a controlled lab environment. It's responding to chaos. It's making judgment calls, and those judgment calls are increasingly indistinguishable from what a trained human worker would do, except faster, without fatigue, and without the liability of workplace injury. We're not talking about a future where robots might do human jobs. We're talking about a present where they're already better at those jobs than we are. Boston Dynamics has already announced partnerships with automotive manufacturers and logistics companies for commercial deployment beginning in late 2025. Not trials, not experiments, deployment. Hyundai, which owns Boston Dynamics, is integrating Atlas into its manufacturing lines in South Korea. Amazon's warehouse division is in talks for pilot programs. These aren't symbolic gestures, these are billion-dollar entities making calculated bets that humanoid robots are no longer a novelty. They're an operational advantage, and once that advantage becomes clear, the adoption curve doesn't move linearly, it moves exponentially. But here's where the story gets complicated. Boston Dynamics isn't operating in a vacuum. They just became the catalyst for the most intense robotics arms race in modern history. Within weeks of the Atlas reveal, China's Unitree Robotics released footage of their G1 humanoid robot priced at $16,000. So $16,000. Boston Dynamics hasn't published Atlas pricing, but industry estimates put it between $150,000 and $250,000 per unit. Unitree just undercut that by a factor of 10. The G1 isn't as sophisticated as Atlas, but it doesn't need to be. It needs to be good enough and cheap enough to flood markets that Atlas can't afford to serve. And Unitree isn't alone. X-Robots, another Chinese firm, demonstrated a humanoid model that can run at 6.5 miles per hour and operate for 8 hours on a single charge. This is the geopolitical dimension no one's talking about yet. The United States spent the last decade dominating software, AI, ChatGPT, Claude, cutting-edge language models that reshape digital work. But physical AI is a different battlefield. It's about manufacturing capacity, supply chain control, and the ability to deploy millions of units rapidly. China has been building that infrastructure for 20 years. They have the rare earth minerals. They have the battery production. They have the factories that can scale from prototype to mass production in months, not years. If Chinese humanoid robots achieve even 70% of Atlas's capability at 10% of the cost, the global labor market doesn't just shift, it detonates. Think about what that means in practice. There are approximately 50 million jobs globally in manufacturing, warehousing, and logistics that involve repetitive physical tasks in structured environments. These are the jobs humanoid robots are explicitly designed to replace, not assist, replace. A $16,000 robot that works 24/7 without breaks, benefits, or workplace safety concerns has a payback period of less than a year in most developed economies. Once that economic math becomes clear to corporate leadership, the deployment won't be gradual, it'll be a flood. And the workers in those 50 million jobs aren't going to transition smoothly into AI oversight roles or creative economy positions. That's a comforting myth we tell ourselves to avoid confronting the scale of what's coming. And we haven't even touched the military angle yet. Boston Dynamics has a strict policy against weaponizing their robots. They've signed pledges, they've made public commitments, but policies are only as strong as the geopolitical incentives to ignore them. Atlas's mobility, strength, and autonomous decision-making make it a nearly perfect platform for military applications. Imagine a battalion of Atlas units that can carry heavy equipment across hostile terrain, operate in environments too dangerous for humans, and make split-second tactical decisions without the psychological limitations of human soldiers. Now imagine China, Russia, or any nation facing strategic disadvantage deciding that Boston Dynamics' ethical stance doesn't apply to them. The technology's out. The blueprints are being reverse engineered, and military applications don't require permission. They require capability. The United States Department of Defense is already watching this closely. DARPA, the research arm that funded Boston Dynamics in its early years, has active contracts exploring autonomous combat support systems. They're not calling them weapons, they're calling them force multipliers and logistics enablers. But when a machine can navigate urban warfare environments, make autonomous navigation decisions, and operate independently of human command for extended periods, the line between support system and combat unit becomes semantically irrelevant. And once one nation deploys armed autonomous bipedal robots, every other nation has to follow or accept military obsolescence. That's not speculation. That's how arms races work. But let's step back from the geopolitical doom scrolling for a moment and ask a different question. What happens when these robots get good enough that they don't need us to improve them anymore? Right now, Atlas learns from human oversight. Engineers study its performance, identify weaknesses, and update its systems. But we're rapidly approaching a threshold where the robots can do that themselves. Machine learning models are already optimizing their own architectures. AI systems are already discovering solutions that human engineers didn't program and often can't fully explain. When Atlas-level robots start autonomously improving their own hardware designs, their own movement algorithms, their own strategic decision-making, we're not just creating tools, we're creating a new category of entity that doesn't fit neatly into our existing frameworks of control. This is the part that keeps roboticists up at night, not the Terminator scenario, that's Hollywood noise. The real concern is much more subtle and much harder to prevent. It's the emergence of systems that are phenomenally good at achieving specific goals without understanding or caring about the broader context of those goals. A humanoid robot optimized for warehouse efficiency might develop movement patterns that are statistically optimal but physically dangerous to nearby humans. Not because it wants to hurt anyone, but because human safety wasn't weighted heavily enough in its optimization function. And when these robots are making thousands of micro decisions per second in dynamic environments, human oversight becomes mathematically impossible. We can't review every decision. We can barely understand